Bismillahirrahmanirrahim. We start our lecture. Today is our first lecture of vectors, and our topic is cross product. Our topic is cross product. Okay. Okay. Let us suppose for a while that this is vector OA.
सर ये P1 के वेक्टर्स हैं?
No, no. P1 vector further पे और के vectors.
हाँ वही सर वही.
Further पे और के vectors. Yes. Paper 1 के.
ठीक है.
Yeah. OA is equal to 3i plus 4j plus 5k, and OB is equal to 2i plus minus 3j plus 2k. Okay. Consider a determinant. Consider a determinant whose first row is the unit vectors I, j, k, and whose second row is the vector components of the vectors of OA. You know, this 3 over here, this 4 over here, and this 5 over here. And then the third row is the numbers, the component of the vectors of component vectors of OB. Okay. Okay. Now let's expand this determinant. You know, you have done too much practice of determinant expanding, and you know that if you expand this determinant, you can obtain you're obtaining another vector. Okay. A determinant, we have formed a determinant whose first row is ijk unit vectors, then whose second row is the component vectors of OA, or we can say that the second row vector is the vector OA, and the third row vector is the vector OB. Okay. Now let's expand it. We obtained another vector, but we do not know what kind of vector it is. What we did, we started with, you know, we considered two vectors. We considered two vectors, and using these two vectors, we made a determinant. We made a determinant, okay, whose first row was ijk vectors. Then we expanded that determinant. We expanded that determinant. We expanded that determinant. We expanded it like this. This is how we expanded it. And we obtained a vector which upon simplification becomes this way. But I'm just wondering what kind of vector it is. You know, OA is taking its place in the second row, and OB is in the third row, and the first row is ijk. And we have obtained another vector. We do not know the properties of this vector. We do not know the properties of this vector, Let's call it OC. Let's call it OC. This is a vector which is obtained like this, that I formed a determinant. IJK was the first row, and 3, 4, 5, the component vectors of OA were the first, second row, and 2, minus 3, 2, the component vectors of OB became its third row, and we expanded this determinant, and we obtained a vector OC. I'm interested in knowing the properties of this OC vector. Okay, let's take the dot product of OC with OA. Let's take the dot product of OC with OA. Let's take the dot product of OC vector with OA. Okay. If we try to calculate the dot product, the properties of dot product. I think if you have done P3, you must be knowing. It's 69 plus 16, and 17 multiplied to 5 gives you what? 85. 85 minus 85 is equal to 0. The dot product of OC with OA is 0. What should I conclude? What must be my conclusion? I should say that OC is perpendicular to OA. OC is perpendicular to OA. Okay. Let us calculate the dot product of OC with OB. Let's calculate the dot product of OC with OB. We calculate it. 2 minus 3, 2 dot 23, 4 minus 17. And it becomes 2 into 23 plus 4 into minus 3 plus 2 into minus 17. It is equal to 46 minus 6 minus 34. Minus 34 minus 12. Okay. Sorry. 4 into 3, it's minus 12 and minus 34. This thing becomes equal to 0. Oh, that means OC is perpendicular to OB as well. Oh, so OC is perpendicular to OA and OC is perpendicular to OB. So what should I comment about OC? OC is perpendicular to OA, and it is perpendicular to OB. OC is perpendicular to OA and it is perpendicular to OB. I can say that OC is a common perpendicular of OA and OB. And I can add further, I can add a sentence, I can say that OC is perpendicular to the plane containing OA and OB. OC is, let's say this is a plane which contains OA, and which contains OB, and OC is perpendicular to both of them, and it is perpendicular to the plane containing both. OC is perpendicular to the plane containing OA and OB. So that means I have found a method by which I can find a common perpendicular. I can find a perpendicular to plane containing OA and OB. Let's say if I am sick of the plane in which OA and OB are moving, and I want to distance myself, so I would like to go for OC. OC is a vector which is perfectly, perpendicular to OA and OB, and is perpendicular to the plane which contains OA and OB. So OC has clearly distanced itself from the any direction in which OA and OB may move, or any component of the direction in which OA and OB move. I hope you understand it. So I call this as cross product. I call it cross. Cross product means, um, a funny way to describe it is that, when somebody is not talking to some other body, we say that he's cross. So that means OC not liking the plane which contains OA and OB is cross. So OC is a cross product. So in this way, we define the cross product. Cross product is different from vector product. Cross product is represented by this. This cross is very particular, okay? It is mandatory. Sign of this kind of product. It is mandatory. Okay, and it says that it is equal to IJK A1, A2, A3 and B1, B2, B3, where A1, A2, A3 are components of OA. OA is equal to A1I plus A2J plus A3K, and OB is equal to B1I plus B2J plus B3K, okay? Or I can write them like this: A1, A2, A3 and B1, B2, B3. So A1, A2, A3 are the components of the vector OA, and B1, B2, B3 are the components of the vector OB. And cross product, which I represent by cross, is a vector perpendicular to the plane containing OA and OB. So OA cross OB is a vector which is really cross, because it has no component parallel to OA and no parallel to OB. No component of this. So OE is a vector perpendicular to the plane containing OA and OB. Okay. So let's expand this cross product. Let's expand this cross product. Okay, we write it like this. And now when we expand it, we obtain this vector. A2B3 minus A3B2, A1B3 minus A3B1 plus A1B2 minus A2B1. It is this vector, and we can also write it in a column vector shape. A2B3 minus A3B2 and minus A1B3 minus A3B1 and then A1B2 and A2B1. Few students memorize it like this, okay? They directly memorize it's this form. They do not use the determinant to expand it and to find a cross product. They memorize this form, okay? And how they do, how can we memorize this part? It's very easy, okay? It's very easy. I can tell you a trick by which you can memorize it. Okay, now consider a situation. Consider, I have written OA like this. A1, A2, A3, okay? And OB written like this, B1, B2, B3, okay? For OA cross product OB, for the first entry, put a line on them, forget them. For the first entry, calculate this determinant. It's A2B3 minus A3B2. So for the first entry, you will hide the first A1 and B1, okay? And you will calculate the determinant of the remaining entries. A2, you'll multiply A2 with B3 and then minus A3 B2. So in this way, you will find the first entry. For the third entry, you will you will hide these entries A3 and B3. You will multiply A1 with B2 and then minus A2 B1. So A1 B2 minus A2 B1. Okay, this is the method if you do not want to use determinant to expand it. Okay, if you are not interested in using determinant, OA and OB are written in column vector form, and you just directly want to write a column vector which represents OA cross OB. Okay, so now in order to calculate the second entry, what you do is that you hide the second entry and calculate this cross product. A1B3 minus A3B1. And for the reasons which will be clear later on, you just attach a negative sign to it. As you used to calculate the determinant, you used to put a negative sign for the cofactor of the second entry. Over here, you will attach a negative sign to the second entry. Okay, so this is how you can directly calculate the cross product if you are not interested in using the determinant method. I hope you understand it. Let me do it again for you. I'll use both techniques, okay? For example, if OA is 372 and OB is 415, okay? Now OA cross OB. For this, in order to find its first entry, I will put a line on the first entry of OA and OB. And then I'll multiply 7 with 5 and subtract the product of 2 and 1. So this gives me 35 minus 2. So in this way, I found the first entry, okay? Now, if I want to calculate the third entry, I'll put a cross on, I'll hide the third entry of OA and OB. And then I'll calculate this determinant product 3 into 1 minus 7 into 4. That means 3 minus 28. And in this way, I will calculate the third entry. Okay. Now, for the second entry, I will hide this 7 and 1. I'll put a line on them. And then I'll multiply 3 with 15 and 2 with 4. 15 minus 8. And I will put a negative sign over here, as I used to put for the second, when I will use to expand the determinant by the first row. So this is how I have calculated the cross product. And when I simplify it, I get 33 minus 7 minus 25. So this is cross product, OA cross OB. Now, if you're not interested in this method, you can use OA cross OB, old method of, expanding by the determinant. Writing the vector which occurs first in order should be the second row, okay? And the vector which occurs second in order should become the third row. Now we expand it. I think you are quite expert in expanding the like this. Okay. So this is how you can calculate. Yeah, is it clear to all of you? Beta, is it clear? Hello? Okay. Now this is the cross product. We move on to the definitions of cross product. We discuss its various properties. We discuss its various properties, okay? We compare it with scalar product. We compare it with a scalar product, okay? Fifth point. The fifth point is comparison of dot product with cross product. Okay. We make a column like this. We say dot product. And we say cross product. The very first thing that I would like to comment on over here is that in dot product, you multiply a vector. You multiply a vector with vector and you get a scalar. That is the very first thing about dot product. Dot product is also known as a scalar product. Okay. But in cross product, you multiply vector in such a way that you get a vector. And it is due to this reason that cross product is also called vector product. Okay. And the second thing is that dot product is commutative. Dot product is commutative. It is not commutative. What is the meaning of being commutative? Commutative means that the order does not matter. In dot product, OA dot OB is equal to OB dot OA. But in cross product, OA cross OB is not equal to OB cross OA. in cross product, order does matter. In fact, OA cross OB is equal to minus of OB cross OA. In fact, OA cross OB is equal to minus OB cross OA. So this is dot product. This is a comparison of dot product and vector product. Okay. Now comes the second comparison. If OA is equal to A1I plus A2J plus A3K and OB is equal to B1I plus B2J plus B3K, then OA dot, this dot is significant as it appears in the name, dot product. Dot product represented by a dot, okay? Dot product represented by a dot is equivalent to A1 B1 plus A2 B2 plus A3 B3. Dot product is equal to A1 B1 plus A2 B2 plus A3 B3. And in case of cross product, OA cross OB is either represented by this determinant or after it has been expanded and simplified, it becomes this thing. Like this, okay? So these two are very different, okay? The fourth point is that scalar product maximizes scalar product maximizes when two vectors are parallel. When two vectors which are to be multiplied are parallel, and vector product maximizes when two vectors to be multiplied are perpendicular to each other. Are perpendicular to each other. And note that if they are perpendicular to each other, their product is still perpendicular to both. So that means vector product maximizes when the two vectors to be multiplied are perpendicular to each other. Okay. Now consider, I haven't yet defined them. I haven't defined cross product yet. But about dot product, you know that OA dot OB is by definition equal to this. OA dot OB by definition is equal to OA dot OB cos of theta. Whereas cross product in comparison is this thing by definition. And with this a unit vector, there are two differences. The one is this difference of cos theta and sin theta. One difference is this of cos theta and sin theta, and another difference is of this n vector. N is a unit vector perpendicular to the plane containing OA and OB. To the plane containing OA and OB. The direction of cross product is given by right hand grip rule. The sixth point is direction. Since dot product is not a vector, so there is no concept of direction involved in dot product or scalar product, because the product itself is not a vector quantity. But over here, direction is given by right hand grip rule. Right hand grip rule. How will I explain this right hand grip rule?
सर अगर आउट ऑफ द पेज आ रहा है तो ऊपर की तरफ होगा और अगर
जी बिल्कुल.
नीचे जा रहा है तो
This is OA, this is OB, and this is the plane which contains OA and OB. Okay. You place your hand, your right hand, with your fingers like this. Okay. And your thumb is pointing over here. Now, when you fold your fingers from OA to OB, the thumb being perpendicular to your fingers, point is perpendicular to the plane which contains OA and OB, and thumb points towards the direction of the cross product. Okay. You consider a situation. I tried to show it with the help of my consider the video in which these are the two pens. Okay. Now, if the black pen is appearing first in order and the red pen is written in the second at second place, then you use this cross your right hand and curl your finger towards the vector which occurs second in the product. Then you can see that thumb points towards the direction of the product. Thumb points towards the direction of the product. Okay. The thumb points towards the direction of the product. See this, consider again, see them again. Okay. Now the black pen appears first in order and red pen appears in the second in order. You place your right hand like this and fold your fingers towards the second vector, and the thumb points towards the product. So this is how you calculate the direction. This is how you know the direction of cross product. This is how you know the direction of cross product. Okay. So this is the direction of cross product is given with the help of right hand grip rule. Now the seventh point is products. Unit vectors. The product involving unit vectors. How do we calculate? How do we calculate scalar product and vector product of ijk? Okay. Okay. You know that I dot I is equal to 1 into 1 and cos of 0, because you know that the angle between I with itself is 0 and I dot I is 0. So this makes it 1. J dot J is 1. K dot K is 1. And I dot J being perpendicular to each other. I dot J being perpendicular to each other, their dot product is 0. J dot I is 0. I dot K is 0. K dot I is 0. And J dot K is 0. And K dot J is 0. So this is here you have applied the concept of scalar product to the unit vectors. In case of cross product, I'm not going to explain. You will have to use right hand grip rule. You know what will give you, what will be I dot j. You know the magnitude of I is 1, the magnitude of j is 1, and sine 90 is 1. And then this n vector is what? N is the perpendicular to the plane containing I and j. And if you apply the right hand grip rule, you will see that this n is actually k, because so I cross j is equal to k. So how can I memorize lot of products, cross products of this ijk? I've the shortcut to this question is that I form a clockwise circle. I form a clockwise circle, and I call three components of this circle as ijk, like this. Now I cross j moving clockwise is equal to k. You can verify it by applying right hand grip rule. And j cross k is I. J cross k is I using using a clockwise rotation. And then k cross I is equal to j. K cross I is equal to j. Okay. And if you move and in reverse, if you move anti-clockwise, you were using earlier you were using clockwise, you were moving clockwise. Now moving from j to I, if you move like this, j cross I is equal to minus k, because your movement is opposite to the clockwise direction. Okay. And now I cross j, I cross k is equal to minus j, and k cross j is equal to minus I. So this is how you can apply this cross product to unit vectors, and you can use this circle drawn in clockwise direction. So this is the application of cross product on the unit vectors. This is the application of cross product on the unit vectors. Okay. Now, if you have done some, if you have some acquaintance with physics, you can see that work done, which is a scalar quantity, is actually a dot product of force and displacement in 3 dimensions. If you have a force like this, 6I plus 2j plus 5k, and the body covers a displacement of 2I plus 3j plus 4k in space under the action of this force, then the work done is equal to 6 into 2 plus 2 into 3 plus 5 into 4. In this way, you can calculate the work done. Okay.
फोर्स को कैसे लिख सकते हैं वेक्टर की फॉर्म में?
जी बेटा,
फोर्स को हम वेक्टर की फॉर्म में कैसे लिख सकते हैं?
We don't write the dot product in matrix form. You know, this is scalar product. I've just given you, you know, as the lecture is going on, this is a column moving over here. The right hand side column is for the scalar products. And over here, on the right side, you, for example, torque or moment is the cross product of moment arm and force. If you have a cross, if moment arm is equal to 2I plus 3j plus 4k, and the force that is acting is 6I plus 2j plus 5k, you will calculate torque by writing it like this and expanding this determinant. It will give you the moment of this force when the moment, where moment arm is from the pivot is equal to this. This will give you the moment. So the moment is a cross product. Similarly, if you're interested in more example, power being a scalar quantity is a dot product of force and velocity. So if you know the force and if you know the velocity vector in 3-dimensional space, you can calculate the power. And over here, you should note that torque is the cross product of moment arm and force. Velocity vector, if you have done circular motion of A2, you will see that the velocity, linear velocity, is the cross product of radius and angular velocity. And similarly, electric flux is the dot product of electric field intensity and the area. And the magnetic flux is also the dot product of magnetic flux density and area. Whereas in the case of cross product, the force acting on a charged particle is given by V cross B, and force on a wire carrying current and placed in a magnetic field, length cross B gives you a vector which when multiplied to current will give you the force. So I don't, since this is not a physics class, I've just quickly mentioned these points because I think that mentioning, even if we are not explaining anything properly, just mentioning is also important because it sometimes helps you when you are doing some really technical thing and you just have an idea, yeah, this thing links to something like that. Yeah, have you understood everything about cross product or not? Hello, do you have any questions?
No, sir.
Hello,
No, sir.
you don't have any questions? Hello, then I stop recording.